can't see it with the naked eye. But scientists at UCLA think they've captured a glimpse, and that's where Eyewitness News reporter Brian Jenkins is standing by now with a live update. Brian?
Well, Mark, you can't see it with the naked eye or with many telescopes because it's obscured by dust particles that reflect in space, reflect a lot of unwanted light. But one UCLA researcher used the Hubble telescope to take a closer look, and what he found left the world of astronomy starstruck. They're pretty calm at UCLA's Infrared Imaging Detector Lab, considering the worldwide excitement among astronomers over UCLA researcher Don Feiger's new pictures. This is a composite of two pictures taken by the Hubble Space Telescope on September 13th and 14th, based on Feiger's coordinates. The purple haze is a nebula of gas burned from a star now believed to be the largest ever seen.
The luminosity of the star, or the actual amount of energy it's emitting, implies to us that the star itself might be 100 times the mass of our sun. There are only about half a dozen stars like this around our galaxy. So this star is in a very rare stage of evolution. The major impact here is twofold: the evolution of stars, number one, and number two, the formation of stars. Most star formation theories have a hard time accommodating supermassive stars. Well, if we're correct, then this was more massive when it was born than any other star we know. This is a great test for star formation theories.
Feiger and his lab associates are currently working on an advanced spectrometer. They hope to finish it by next summer and use it to confirm that Feiger's star is no optical illusion. Other researchers have suggested that Feiger's star may be a clump of several stars, so the research continues. Reporting live at UCLA, Brian Jenkins, ABC 7 Eyewitness News.
All right, thank you very much, Brian. We go now to earthly matters. Hurricane Pauline.
Beside finding a public phone is whether or not it's still on the phone and how horrible does it smell.
It's not absolutely certain that payphone prices will rise, but if most industry analysts are right, customers will have to dig even deeper into their pockets for some extra change. Antonio Mora, ABC News, New York.
From the Hubble telescope today, a glimpse of what is believed to be the most powerful star ever detected. Pistol star, as it's called, gives off 10 million times more energy than the sun. 10 million times more. But don't look for it in the sky with your naked eye. Cosmic dust absorbs most of its light, and Pistol star cannot be seen by the naked eye alone. When we come back, men and boys who chew tobacco.
Might be the biggest and brightest star in the known universe. It's called a Pistol star and gets its name from its pistol-shaped gaseous cloud. The image of the Pistol star was captured by the Hubble Space Telescope. Astronomers say it is 25,000 light years from Earth, and it's about 10 million times more powerful than the sun.
Amazing.
Spectacular.
Mm-hmm. Mark Thompson here right now. Mark, you and I were just chatting about possible change in some weather.
They call it the Pistol star, and it generates more energy in 6 seconds than our own sun does in an entire year. Ron Olson has more.
Astronauts go up to repair the Hubble telescope. They also give it something new, a tiny chip that gives the scope infrared capability. The Hubble can now pierce the veil of interstellar dust and see objects that generate heat. It can search beyond the thousands of stars astronomers have been watching from Earth.
The discovery came when UCLA team leader Don Feiger decided to take that new technology on board the Hubble and point it at the Pistol star.
Feiger and his team did not find the star. Astronomers already knew it was there. What the UCLA team did find is that it is more intense, generating more raw energy than any star they've ever seen.
This thing generates perhaps 10 million times the power of the sun.
Named for the shape of the clouds of stellar dust and gas that surround it, the Pistol star is a giant. It would occupy all the space in our solar system within the Earth's orbit around the sun. Located near the center of the Milky Way, it is still far, far away from Earth.
So we're talking about light, which travels at 186,000 miles per second, taking 25,000 years to get here from this object.
McLean says the Pistol star is probably just the beginning. The UCLA team has analyzed only 2% of the data received from the Hubble telescope over a 24-hour period, and the Hubble is still up there searching the cosmos for pictures that no one has seen before. At UCLA, Ron Olson, Channel 5, News at 10.
Meantime, across town, researchers at the Jet Propulsion Laboratory have made exciting new discoveries about the planet Mars.
Energy source, or at least helping us better understand our place in the universe. Dave Bailey, CBS News, Houston.
Well, we told you about it yesterday, the biggest, brightest star in the universe. It doesn't have a Hollywood address or even reside on this planet, for which we're grateful. This is a celestial giant called the Pistol Star. It is 10 million times more powerful than our sun, but cannot be seen with the naked eye from Earth. The power and size of the Pistol Star were recently identified by UCLA researchers using the Hubble Space Telescope. Don Feiger is the astronomer who, along with his colleague Mark Morris, led a team of investigators studying the star. He joins us this morning from CBS station KCBS in Los Angeles. Also with us is Bruce Margon, a professor of astronomy at the University of Washington. He has worked extensively with the Hubble Space Telescope. Professor Margon joins us from our affiliate, KIRO-TV in Seattle. Good morning to both of you.
Hi there.
Good morning.
Thanks for joining us. Certainly a lot of excitement in the skies this last couple of years. Don Feiger, let's start with you. I know that the star had actually been seen before, but bring us up to date with when you first saw it, and certainly there had to be a great deal of excitement about that.
That's right. It was actually first seen in the early 90s by Japanese and South African groups. But we started studying it in 93, 94 as part of my PhD thesis, which was completed in 95. Our latest observations were done with the Hubble Space Telescope, as you say, and it has confirmed our suspicions about the nature of the star, and we believe now that it may be the most luminous known.
It certainly is huge. We're going to talk about the size of it compared to what we had known before about stars. The Hubble telescope really did make this possible, though.
The Hubble really revealed the relationship between the nebula, the gas surrounding the star, and the star itself. So it adds more information to our story about this star. It's totally consistent with our suspicion that this is a supermassive star.
Well, Dr. Margon, we'll bring you in now. You work with the Hubble telescope very closely. What special features did it have that made us able to see this? I understand we couldn't see through the dust before. How does Hubble help us?
Well, you're right. The direction that the star is located in has a very thick layer of diffuse dust, and that makes it invisible from normal ground-based telescopes. If instead of using visible optical light that your eyeball can see, you look at infrared light instead, that kind of light does penetrate the dust. So this observation was made by Hubble with an infrared camera. Now, it's possible to observe in the infrared from ground-based telescopes as well, but Hubble has the added advantage of being up above the sloshing Earth's atmosphere that blurs all pictures on the ground, no matter how good your telescope is. So Hubble sort of has a 1-2 punch to bring to this particular observation. First, observing at infrared light, and second, being able to take an exceptionally sharp image of a very, very complex and small region above the Earth's atmosphere.
We were looking at the picture ourselves earlier. It is remarkable. Dr. Feiger, tell us about this star itself. How big is it, if in fact it is one star?
Well, actually, the size isn't the main point of our study. The size is interesting, but there definitely are stars which are physically larger. What's perhaps more interesting is that we think it might be emitting 10 million times the power of the sun, as you said earlier. Also, you can see a nebula which surrounds the star. This nebula is composed of ionized gas, and we believe, and we think this picture now shows, that this material was once part of the star. And so you're seeing the outer layers of the star which were blown out in massive eruptions perhaps a few thousand years ago.
Which means it's burning very, very quickly in relation to the speed of our sun burning. We don't expect this star to be around much longer then, do we, in terms of space-time?
Right, absolutely not. We think it's only a few million years old, and it will run out of energy relatively soon, maybe in another few million years.
Is it possible this star, some have said, is so dense it can't be one? Is it possible, do you think, that there is actually more than one star and they're just close together?
Absolutely. In fact, many claims of high luminosity stars have fallen to that fate, that actually they're composed of 2, 3, or 4 stars. And we're very interested in getting the highest resolution data possible to determine if this star is single. All the data we have right now are consistent with this star being single.
Dr. Margon, what about this star so big? Does it change the way we think about how the galaxy was formed, how our sun was formed?
Certainly, much of what we think we know about how stars are formed is theoretical rather than directly observed. And the issue of what is the maximum mass star that you can make, how heavy can the heaviest star be, It's very difficult to calculate with a pencil and paper, and a much more straightforward way to do it is to go out, observe, and find the heaviest thing you can, and then you know that any theory has to agree with that. And in one sense, that's one of the interesting pieces of significance of this observation, is now any theory that comes along is going to have to be able to produce a star that weighs up to 200 times what our own sun weighs.
We look at this being in the center of the galaxy. Is that coincidence, or do you think there's a reason why this particular star that we now call Pistol is the center?
I think that's a fantastically interesting question. That is that a coincidence or not? I don't know. Don, what do you think?
Yeah, absolutely. That's part of our study. We look for supermassive stars in our galactic center. We found many of them, this being the most extreme example, and we want to know if the stars in the galactic center are preferentially more massive than ones that are formed out in the disk where the sun is.
Is it important for us to understand how stars are born? Will this help us, Don?
Well, I think we seek to understand all the major features of the universe. Certainly, you can just look up in your night sky and see many, many stars. I think ultimately we want to know how they form, why they form, what are the processes, what physics is involved, and what to expect for the history of our galaxy and the universe.
Well, gentlemen, your discovery is certainly making more scientists out there every day more excited and making more kids want to be scientists. Dr. Don Feiger and Dr. Bruce Margon, we certainly thank you both for joining us this morning.
Thank you.
We are still making discoveries about Mars. Scientists said yesterday.
Most people think of space. What comes to mind are names like John Glenn and Neil Armstrong. When scientists think about space, the name that comes to mind is Hubble, the space telescope we sent on a